Good night, everyone. Mechanics of Materials, Chapter 10, Strain Transformation. Let's solve an interesting problem in strain transformation. Let's consider a square plate of ABCD handling a planar stress like sigma y and sigma x with no shear stress. Sigma y is 200 kg over centimeter squared and sigma x is 1000 kg over centimeter squared. We want to determine the change in length of hypotenuse AC. If Poisson's ratio is provided to be zero point 0.9 and modulus of elasticity of the plate is 2 times 10 to 6 kg over centimeter squared. So first of all, if we want to calculate the change of AC, first we need to calculate the length of hypotenuse itself. So because each dimension of the square is 40 centimeters, hypotenuse AC is 40 square 2. And then from the Hooke's law, we do know epsilon x is 1 over E in planar stress sigma x minus nu times sigma y. Likewise, sigma y is 1 over E sigma y minus nu times sigma x. And then if we replace the data provided in problem statement to calculate epsilon x and epsilon y and jot them down, we can easily get epsilon x is 5.3 times 10 to negative 4 and epsilon y is a negative 2.5 times 10 to negative 4 and they are dimensionless. If we have epsilon x and epsilon y and then we do know delta in x direction which is AB is AB times epsilon x which we already have it here. Likewise delta in y direction is BC initial length times epsilon in y direction, and if we do know the initial AB is 40 times epsilon x which is 5.3 10 to negative 4, we can get this amount of centimeters. And likewise for epsilon y, we have either increase or decrease in the length of a x and y directions. So when we have that, we do know the length after deformation, if we call it like a prime b prime is ab plus delta x. Likewise b prime c prime is bc plus delta y in y direction. So, and the new hypotenuse, which is a prime c prime, you can also call that ac prime, but we just like be more accurate and just consider it like a prime. And that's a square root of a prime b prime squared plus b prime c prime squared. The reason is a is not moving, so you can replace it like by, if you replace it like a here or a prime, both are correct. And then delta AC change in hypotenuse is a prime c prime minus AC. The deformed one minus the initial one gives us the diagonal cha change in the length of AC. So a prime b prime is 40 plus the delta x. The other one is 40 minus 0.01, which is 39.99. They are in matters of the length, so they are centimeters. Definitely they are centimeters. Likewise, we can calculate it for a prime c prime and then subtract it from the original one, and it just gives us a numeric value of 7.92 10 to a negative 3 centimeters for change in diagonal AC. We also can solve this problem in far simpler approach with a strain transformation. That was the geometry approach, solution 1, and this is strain transformation with the help of chapter 10, which is a far a faster solution. So because there is no shear stress in this plane, you can easily see we just have sigma x and sigma y. No shear stress apply on the plane. So that just gives us tau, or shear stress is equal to 0 as soon as we know tau is 0. Tau is equal to g times gamma. That's Hooke's law in shear, and that just says as denominator shear modulus is a number. It cannot be zero. So tau is uh, zero gives us gamma is zero. As soon as we do know that, we can just jump down to our equation. Delta AC, we already know that's AC times epsilon AC. And if we just jot down this strain transformation, do you remember this equation? I will provide you with the link to this video for strain transformation. Epsilon AC is epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cosine of 2 theta plus epsilon x y sine of 2 theta. And because this is a square, a AC stands in a theta 45 degrees from the horizon. So previously we know that from previous slide, we do know that gamma xy is equal to 0. So epsilon xy is just half of that. That should be 0 as well. And also cosine of 90 degree, which is 2 theta, is a 0. So these two second terms just removed from our equation, and we are only left with this part of delta AC. And we already calculated, we do know what the epsilon x is, what epsilon y is. If we just add them up together and divide it by 2, it just simply gives us 1.4 times 10 to negative 4. And AC is 40 square 2, and delta AC is AC times epsilon AC. So if you just multiply this numeric value, it just gives you the same numeric value, 7.92 times to negative 3 centimeters. And if we make a comparison between two solutions, like solution 1 geometry and solution 2 strain transformation, it just gives us the same numeric value for delta AC, and we do strongly recommend the second solution for in terms of simplicity. Thank you. We'll solve more problems.